Remember when Tangtang said,
I'll buff my Stargate with Endfield tech.
yeah, I just made a calculator. So to help our Supreme Chief's IQ a little bit, I used the power of Enfield Industries and made a 2-bit adder, which means this can add up to 6, which is this thing plus this thing equals this thing. If you do want to try making this and understanding it a little more, the requirements are having 0 sanity, unemployment, and a tiny bit of computing knowledge. So let's start with. There are 4 kinds of gates used in an adder circuit: an OR gate, AND gate, NOT gate, and XOR gate. An OR gate is just a converger. If the first or second input is active, the output will be active. Yeah, that's it. If you have conveyors connected to a protocol stash like this, it will output that item. But if you have 2 outputs, it will alternate just like a splitter. By adding a converger in front of one of the outputs, prioritizes the output without the converger. So when you have 2 active inputs, both outputs will be activated. We will assume the conveyor with the converger is our output for an AND gate and the other as redundant. In a real NOT gate, there is an output always sending out a signal. When an input is turned on, it blocks this signal, resulting in an inverting signal. To simulate this action, use the converger with a splitter next to it and a splitter with control ports to separate the 2 items. In here, the bug flower seeds are used as a force signal. So when the input with sand leaf seeds is sent, it will cut off this signal, outputting an inactive signal. Note that if sometimes the converger isn't working, just rebuild it. An XOR gate is a combination of all the gates in this way. We will use 2 protocol stashes with sand leaf seeds as our input 1 and 2, and bug flower as our force signal. The center is 2 NOT gates that are mirrored and merged closer together for compatibility. The input is then flipped into AND gates, where the redundant signal goes back into the stash, and the actual output is combined into a converger, acting as an OR gate. If both inputs are active, the output is inactive, but only when either input 1 or 2 is active, then the output is active. Additionally, you can face having an input with multiple items caused by an AND or OR gate. If you do need to use this input for a NOT gate, you can split the items like so and combine the input afterwards. Binary is used to represent numbers into zeros and ones. So in 1 bit, a 0 represents 0 and 1 represents 1. But in 2 bits, 0, 0 represents 0, 0, 1 represents 1, 1, 0 represents 2, and 1, 1 represents 3, and so on. Yeah, that's all you need to know about binary for now. A seed picking unit can produce 2 seeds from one plant. This can be used for efficiency and consistent signals. Let's just say you have used an input for one gate, but you need to use that same input for another gate. Using a splitter halves the input, which can cause problems, so just use the other port. Ran out of ports, make a new farm. Create 4 farms to represent 2 2-bit numbers. I'll label this as so. I'll explain how to use this in a bit as we go on about. There are 2 kinds, half adder and full adder. A half is used for adding only 2 1-bit numbers, and a full is used to add higher bits by stacking. For the first circuit, we will use a half adder to our advantage to reduce space used. These are the inputs, and these are the outputs. Same thing as reading binary, the cout is the most significant bit, and the sum is the least significant bit. So adding 1 plus 1 will give 1 0 equals 2, and adding 0 and 1 will give 0 1 equals 1. For the sum, an XOR gate is used. This will be our first bit. For the cout, an AND gate is used. This is where we use the second port from the input because we can't use the same input for XOR. The full adder takes up even more space, as now we need 2 XOR gates, meaning 4 forced signals. Let's look at the sum first. Same as before, an XOR gate is used using the inputs A1 and B1. The output is then used as an input for the next XOR gate. The Cin is the cout from the half adder. I used citron powder as forced signal because the input from the first XOR gate may have both sand leaf and bug flower seeds. This is where the separating multiple items concept comes in. This sum will be our second bit. The cout has 2 AND gates. one for A1 and B1, and one for C in from the C out of the half adder, and the output of the first XOR gate. With an OR gate at the end, this will be our MSB. By arranging them from LSB to MSB, you can finally add numbers up to 6. Adding and removing seed picking units from the inputs can represent zeros and ones. So for example, if you want to add 2 and 3, the first number is 1 0 and the second is 1 1. The output should result in 1 0 1. Here's a quick time lapse, taking roughly 5 minutes. Congrats, you've just learned the basics of addition. Many problems were encountered when making this. This takes super long to calculate due to all the conveyors and unit clocking. Either you make this as efficient as possible by reducing the length, or somehow implement liquids for calculation. Also, Tsingbo was too small for a 3-bit adder, but I definitely think this is possible with the core AIC areas in Valley 4 and Wuling City, which I'm not sacrificing my SC battery from, by the way. All logic gates and the whole adder blueprint is in the description. Have fun, bye.